hello, Mr. Ryan, right?
Yeah.
Okay, so we given an English word. Okay, say H-E English letters. Hello, E-R-I-C-R-Y-A.
Does it have to be an actual word?
No, it doesn't. It could be random English letters. We're given a string which contains only lowercase English characters, and we also given a k. For example, like k equals 3 here. So we want to find out the maximum number of vowels. What's vowels? Vowels, okay?
E-I-O-U.
That is size k substring. Okay, so basically in this string, we want to find out the substring which is size of k, right? And we want to find out which one, how many vowels it contains. So in this case, how many vowels, the maximum number of vowels you can find in a substring which is k plus 3.
The E.
How many?
2.
2. Which one is it?
E. I said E.
E. Yeah, this one, right? Substring. Yeah. Any more substring contains more than 2?
No.
Which
R
part?
R is not the vowel.
But
You mean 3 like a window?
Yeah, a window. Yes, you mentioned
K
the
is the word K.
Okay, size k. Yeah, yes.
Yeah, that's the
Okay,
size.
so for this one, if we change k equals 5,
And
so what's the answer? How many vowels we can find? Vowels, by the way, is
it
A, E, I, O, U.
Is
Okay.
it L-E-L-L-O-E?
So you say this one.
Yeah, is it?
1, 2, 3. Okay, any more? There could be multiple optimum, right?
There's also O-E-R-I.
What if k is bigger than how much numbers there are?
That's a good one. If k is bigger than or equal than the length of the s, then you just try to find out the number of vowels in that string, right?
Yeah.
So we return, the number of vowels you can find in the window, which is size of k, substring. Okay. So substring. What's substring? And what's the subsequence? Do you still remember the difference?
Is one like continuous?
Which one is continuous?
Is it substring?
Which one is continuous? Come on here.
Is it substring?
Yeah, substring. We're talking about substring, right? This is continuous. This one is not, right? Subsequence, right? E-R-I-C. Subsequent. E-I-C, right? R-C. R, right?
E-C.
Yeah. So substring is also part of subsequent, right? But not the other way, okay? Subsequence can contain continuous or non-continuous. For each character, you can pick or not pick, right? How many solutions can you find? Given this problem, how can we solve it?
You just move it until the end, and then you have like something or whatever, so you can note how much vowels.
Yes, okay, that's good. That we call it sliding window, right? Size k, right? So k equals 3 here. Okay, so look, how many vowels here? 1, right? And then move on. How many vowels in this window? Still 1, right? Okay, so what happens if I move it to the right? So now I'm...
For K3, the ultimate is O-E-R.
Yeah, I know, but I'm moving, right? The sliding window. Okay, so now the vowel is 1, right? There's only 1 vowel, right? Okay? If I move it to the right, what happened? What happened? If look, E-A-L to A-A-O, what happened now? So what should we update the current window? The current window is the counter to represent the number of vowels in the current window, right? So if we move E-A-L to A-A-O, what letter is removed?
E.
So we need to decrement the vowel by 1, right? But at the same time, O is the new character we need to increment. So it's -1 plus 1, right? Make
It's
sense?
like Q, because E-L-L is a Q, and then you get E, and then you go O. Yeah.
That's right. It's like a cube, but do we need to know what are those? We don't, right? We just need to know how many. Am I right? A counter, a number. So if we get rid of E, we're losing 1 vowel. We have 1 O. We increment 1 vowel. Okay, so now it's still 1. What happens if we move to the right?
L is.
It's not, right? So we don't decrement. Now we have 2 vowels. The E is vowel. Okay. And then same goes to the right, and then we remember the maximum.
Same.
Let's call sliding window, right? Sliding window. This is the optimum, right? Sliding window. Okay. So substring, right? Because it's continuous, we can brute force the substring as well, right? Because it's size k. So how many substrings? How how many substring which is size of k? It's in on, right? On. Make sense? So you can brute force these. You can brute force this substring which is size of k. Usually the substring of different size is on square, right? On square. How many substring here? How many substring? If the size of n, how many substring? We can pick one character for substring which has cn1. There are n choice. If a substring is only one character, right? And we can pick cn2. What's this mean? A substring, we can pick a left boundary, we can pick a right boundary. There are n character, we want to pick 2 characters for the left and right boundary. So this cn2. So this is n plus 1 divided by 2, okay? So this is on square. Okay, so but in this case, which is on, because the size of the substring is k, is fixed. How many substring is actually on minus k, right? On minus k. There are 10 character, okay? Look, 10 character string. The substring which is size of k, which is size of 5. How many substrings? There are 5, right? Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 0. How many substring which is size of 5? 1, 2, 3, 4, 5, 6. Okay, so it's 6. Okay, let's plus 1 here. Okay. Yeah. Okay. So the brute force, we find out the substring and then we check. We just check how many of them. Check how many vowels in each substring, right? And then this is going to take on times k.
Yeah.
Oh, actually, it's not entirely on. It's this one, right? It's on minus k times k. K is smaller than or equal than n, okay? And if k equals n, then the time complexity is on, because it's basically asking that finding the number of vowels in this current substring, okay?
Mm-hmm.
Define the number of vowels. The number of vowels. Maximum, right? As this return the integer. Return the integer, okay? Answer equals 0. At the beginning, we need to construct a window of size k, right? So, for I in range up to k, window equals 0. Okay, window equals 0. Window plus equals the I. If the I is in, actually this SI is in the vowels, which is vowels in V, okay? Vowels. So this is vowels. What's vowels? Vowels is a set of A, E, I, O, U, right? A, E, I, O, U. Okay, I'm going to write it. Vowels. Look, SI, this is the character. If it's in vowels, okay? So that's a true and false, right? True and false. In Python, this is called boolean, right? True or false, right? Yes or no? If we convert it to integer, can you guess what's the value? If we convert it to an integer, right? If you use it as an integer, what's the value? True would be, one of them is 0, one of them is 1. Which one is true? Which one is 1? Which one is 0? Can you guess? Which one makes more sense? True is 1. False is 0. Yes, correct, yes. Look, because we can say if true, right? If something, if x, then we do something, right? So x is true, then we go here. This if satisfies the requirement. And if x is an integer, we can also say if it's non-zero, then we can say if x is the same, right? It's consistent, am I right? Okay? Okay, so look at SI in vowels. This is the boolean. When it's true, then we increment the vowels, right? Windows. Right? Can you sit down, please? Okay, now the answer at the beginning, we know it's at least win, right? The lower bound is win, right? The first window, this is one. Okay, and now we just have to go through the window, right? For I in range, right? Here, K is here, right? I is here, right? We need to start from the next window, the right bound, okay? K to length S. When we move, we take the letter on the right, we remove the letter on the left, right? So look, window plus equal SI, right? SI is this. we are here, right? And then we move. We start from this is the window here, the new window. Si in vowels. Okay, win minus equals S in vowels. Okay, so can you tell me what's this? Look, I'm taking this character. Which is the character I need to remove from the window? First one, which is I minus K, right? This is I. This is I. This is I minus K, am I right? Yeah? 0, 1, 2, 3. 3 minus 3 equals 0. Okay? I minus K. And then answer equals the maximum answer and then the window, right? The window. How many vowels, right? And return answer. Make sense? Sliding window. What's win? The window. The number of vowels in the window, right? The vowels, A, I, O, U, you know that. This is set. What's this doing here? For I in range K, win plus SI in vowels. So after this, the win equals.
It counts how many vowels.
In the which window?
In the mini window.
In the first window, right? In here, right? And then here, this loop start from the second window to the end, right? Every time I take the character on the right, I remove the character on the left. SI in vowels, right? If it's in a vowel, if SI is a character in a vowel, then this equals 1. If it's not, then look, if SI is not a vowel, SI in vowels is false. The converting to integer, which is 0, plus equals 0, minus equals 0, okay? It doesn't change anything, okay? And then this win, after this, window, win is the variable, the number of vowels in the current window, and then we update, we keep the maximum. The time complexity, ON, right? ON, we're just traveling one, right? Make sense? But the thing here is that because we're traveling once, we not even visit the window to count the number of vowels in each window because we just use the variable to update, right? We don't need to count it again, right? If K, look, if K is roughly half of the N, then that's going to be a problem. Because if K is half of N, remember the previous one, N minus K times K. If K is N, N minus K plus 1, okay? If K is roughly N, then this whole thing is ON, right? Okay? But if K is half N, so it's N minus half N times half N. Okay, so this is half N. N minus half N is half N, right? Times half N. So it's N squared, okay? This is slow because for each one, we need to check the number of vowels in each window. That takes another linear time. Yes?
Yes.
Okay, so what happens if K is 1?
The answer is going to be 1.
If there's a vowel.
If K is 1, yes, very interesting. What happens if K is 1? So what's this problem become?
1.
If there's a vowel.
If there's a vowel, yeah, then we return 1, right? Yes? Easy, yeah?
If there isn't a vowel, then it will be 0.
Well done. Then if it's K is 1, then we can just do this, right? Set S, and then we check if A is in set S, E, I, O, U, right? So actually we can just go through the array, and then if you find a vowel, we just return 1, otherwise return 0. Make sense? Okay. K is 1 is up. If K is N, what happened? What happened if K equals N?
Then we find how much N vowels are in N.
Shouldn't you say how many or no how much? These two, ON, right? Obviously. The problem is when K is half N, then that's ON cubic. If we go for the first approach, but for this one, it's still ON time, okay? ON time, because look here is K. This requires OK time, right? The first window. This requires ON minus K plus together is ON. Space complexity O1, okay? What have you learned today? We have a string, yeah?
And you have K and you want to find maximum vowels in substring.
Size K, okay? So we're given a string which contains the lowercase letters.
With the length of K.
Yeah, and we want to find the maximum number of vowels in the substring, which is size of K in the given string, okay?
Lots of solutions.
One of them is fine. What's the solution?
So, one of the solutions, which is the first one, is we have this sliding window. The window and there's K, the window is
I smell something.
length of K, and in the window we have the letters, and so we just set the vowel maximum. So you just need to go through, and then
Okay, so two solutions, yeah? The first one is brute force. We check these each substring size K, and then we count how many vowels in each substring. But we don't need to count each time because we can have a sliding window to update the number of vowels in the current window. We take the new character, we drop the leftmost character, okay? Yeah, that's it for today. Bye-bye.
Bye.
Bye-bye.